Prove that n to the power of 5 and n have the same last digit. To help us with this question, we can consider using Fermat's little theorem, which states that for any prime p and non-negative integer n, p divides n to the power of p minus n, or in other words, n to the power of p minus n is divisible by p. Using this theorem, can you try to prove this? Now, since n to the power of 5 and n have the same last digit, we can rewrite this question as such. N to the power of 5 minus n ends with 0, and thus n to the power of 5 minus n is divisible by 10. Our question is now, prove that 10 divides n to the power of 5 minus n. Now, by Fermat's little theorem, we know that since 5 is a prime, 5 divides n to the power of 5 minus n. Now, we only need to prove that 2 divides n to the power of 5 minus n, since anything that is divisible by 2 and 5 is divisible by 10. Let's factorize n to the power of 5 minus n by taking out n. If n is odd, n to the power of 4 minus 1 is even. And if n is even, n to the power of 4 minus 1 is odd. Therefore, the product of these two numbers must always be even. And thus, 2 divides n to the power of 5 minus n. Working backwards, we can now conclude that 10 divides n to the power of 5 minus n. Thus, n to the power of 5 minus n is divisible by 10. N to the power of 5 minus n ends with 0, and n to the power of 5 and n both have the same last digit. We have solved the problem. Thank you for watching.